Hey guys, so in the last lecture, we have seen the equation of motion for viscous damper. So, in this, the equation of motion of viscous damper, there are three components, that is spring, damper, and mass, spring, and damper. So, this the equation which we got is similar to the RLC circuit, that is resistance, inductance, and capacitance circuit is similar. So, here we have used the Newton's law of Newton's method to find the equation of motion of the damper. So here we have the here we have resolved all the forces. So there are only two forces in upward direction. That is spring force kx, that is spring stiffness into displacement, and the damping force cx dot, that is damping coefficient into velocity. So there are two forces in upward direction. So according to Newton, there should be an equal and opposite force to balance balance these forces. So that force is, let's say, inertia force, that is IF. So that we are taking it as force is m into a mass into acceleration, it is mx double dot. So inertia force is equal to summation of all the external forces. So external forces are kx and cx dot. So now for sign convention, if we are taking the downward force as positive and upward force as negative, then we'll get mx double dot is equal to minus kx minus cx dot. So if we bring all the negative terms on the left hand side, so we'll get this equation mx double dot plus cx dot plus kx is equal to 0. Now if we divide whole equation by mass m, so we'll get x double dot plus c by m x dot plus k x by m is equal to 0. So this is the equation of free damped vibration. Now this is a uh, second order equation. So if we need to solve this equation, so how we can solve this equation? So this is x double dot, so this is the second differential. So the differentiation is of the second power, so it is the second order differentiation, so maximum. So and the power of that order is 1, so second order first power differentiation. So how we can solve this differentiation? So this we can solve by by converting this equation into auxiliary equation, and then finding a solution as cf plus pi, that is complementary function and particular integral. As on the right hand side the of the equation, the values are 0, so there is no constant terms. Therefore the particular integral will be equal to 0. So here the solution will be only cf. So first let's convert this into auxiliary equation. So converting it into auxiliary equation, so how we will convert? So we'll take the assumption that let capital D is equal to d by dt. So capital D is equal to d by dt. So therefore if I substitute this in this, so so d is d by dt, so d square will be d square by dt square, and so on. So here from x double dot we'll get d square x plus c by m x plus c by m dx plus k by m x equal to 0. If I take x as a common, so I will get d square plus c by m d plus k by m x is equal to 0. So if I take x on the right hand side, so it will be multiplied or divided by 0. So we are left with this term. So how we can solve this equation? So as you can see, this is a simple equation of a line. uh, so not line, so it is a simple equation. So how we can solve? So so the solution for this equation is as we know that D uh, is equal to minus B plus or minus under root B square minus 4AC upon 2A. So what is your ABC? So the first term here A is equal to 1, comma B is equal to C by M, and C is equal to K by M. So if I substitute this ABC values here, so I will get D is equal to minus C by M plus or minus under root B square. So that is C by M. Uh, so let's take C square M square, that is B square minus 4 AC. So A is 1 and C is K by M. So C is here K by M. So divided by 2A. So 2 into A is 1. So now if I bring this 2 in a pod, so what will it will be? So C by 2M plus or minus. So here it is 2. So here it will be 1 by 2. So if I want to bring this 2 inside the square root, if I want to take inside the square root, then we need to square this 2. So under root C by 2M whole square. So I have squared it, and if I want to bring in the square, so I have to, so C by 2M whole square, and this 2 will also go here, so it will be divided by 2 square, that is 4. It will be minus K by M. So this is the solution of the auxiliary equation. So what would be our general solution? So here we have got two solutions, that is plus or minus. So suppose if I call this solution as 1 comma 2, so 1 is for plus sign and 2 is for minus sign. So our general solution for this for the real equation, this equation will be in terms of x. So what will the solution of x? So x will be equal to, so x will be equal to a e raised to d1t plus b e raised to d2t. So this is our general solution of uh, the equation of motion of a viscous damper. So now further uh, further if we modify this solution, so we will introduce a new concept, that is critical damping coefficient. So that is critical damping coefficient. Critical damping coefficient. So what is critical damping coefficient? So the value of damping coefficient C, so the value of damping coefficient C that makes the equation within radical sign of equation, so that makes the equation within radical sign of equation. So what do you mean by radical sign? So radical sign means that uh, this the square root term will be tends to equal to 0. So this definition means that the square root term should tends to be equal to 0. So how we can make this term is equal to 0? So let's write this term is equal to 0, c by 2m whole square minus k by m is equal to 0. So when we are saying this term is equal to 0, then the damping coefficient will be cc, not c. So this damping coefficient we will call it as critical damping coefficient. So now taking squares on both the sides, so we'll get cc by 2m and taking this k by m on the right, so k by m, and taking again under root on both the sides, so we'll get cc by 2m is equal to under root k by m. But as we know that k by m, under root k by m, is omega n, so that is omega n. So we got this equation that cc by 2m is omega n, and we can also call cc is equal to 2m omega n. We can also call it as cc is equal to 2m omega n. Now we will introduce a new concept, that is damping factor. So what is damping factor? So by definition it is the ratio of damping coefficient C divided by critical damping coefficient Cc. So it is ratio of C by Cc. But generally, what does it? What is the physical meaning? So its physical meaning is how much the system is having damp. So how much more damping it is having related to the critical damping coefficient. So if I substitute this solution of Cc, so I will get C by what is Cc? That is 2 m omega n. So instead of omega n, I can also write under root k by m. So this so so what is Cc? That is 2m omega n. So let me write 2m omega n. So let's take omega n on the left hand side. So what will be the equation? So zeta omega n is equal to c by 2m. So that is c by 2m. So we will use this equation, that is c by 2m. We will use zeta omega n. So in our previous equation, so here there is a c by 2m, here there is c by 2m, and here is k by m. So here we will use directly this equation. So what will be our solution d12 then? So d12 can be called as minus c by 2m. So it was like minus c by 2m plus or minus under root c by 2m whole square minus k by m. So we will replace this with uh, zeta omega n minus plus or minus under root zeta square omega n square minus k by m. K by m is omega n square. So we will take omega n as a common. So we will get minus zeta plus or minus under root zeta square minus 1. So our solution will be, what is our general solution? That is a e raised to d1 t plus b e raised to d2t. If I replace the values of d here, so our solution, general solution, will be x is equal to a e into minus zeta plus or minus under root, sorry, we will take first plus, uh, so plus under root zeta square minus 1 plus b e raised to minus zeta minus under root zeta square minus 1. So this is our general solution. So now we will discuss various cases for this solution. That is, if zeta is equal to 0, zeta is less than 1, zeta is greater than 1, and zeta is equal to 1. So if zeta is equal to 0, we will call it as undamped vibration, because zeta is equal to 0. Then what is zeta? So zeta is as we know that it is C by Cc. So if it is 0, then C damping coefficient will be 0. So it means that there is no damper. It is an undamped system. Now if zeta is less than 1, so what does it mean that C by Cc is less than 1? So this means that C is less than Cc. So it means that the the system is underdamped. The system is underdamped. If zeta is greater than 1, so this means that the system is overdamped. The damping is high. And if zeta is equal to 1, so it means C is equal to Cc. So which means the system is critically damped. So this means the system is critically damped. So we will see the cases one by one. So I will start with the first case, that is underdamped system. So cases, so first, underdamped system. So what does it mean? That it means that zeta is less than 1. So that means that C is less than Cc. So if zeta is less than 1, then what is our solution? So d12 is omega n under root minus zeta plus or minus under root zeta square minus 1. So if zeta is less than 1, so the zeta square will also be less than 1. So anything less than 1 minus 1, so this will be minus. So the answer of this will be in negative, and under root of negative will be a complex number. So in case to make this positive, we take the complex number out of the equation. So what we'll get is that minus zeta plus or minus I under root, and if we change the sign, so that is 1 minus zeta square. So we have taken minus 10 as a common to make this positive. So now the solution, uh, sorry, uh, the equation was not like this. The equation was like this. So zeta. So now the solution, if I multiply omega n both the sides, so what I will get is minus omega n zeta plus or minus I omega n under root 1 minus zeta square. So now there are two frequencies. So this is the natural frequency, and this the multiplication of omega n natural frequency into 1 minus zeta square. So damping factor, we will call this frequency as damped frequency omega d. So that is omega n under root 1 minus zeta square. We'll call it as a damped frequency. So the solution will be d comma 1 to minus omega n zeta plus or minus I omega d plus or minus I omega d. So now we will apply this in the solution, general solution, and find what is the general solution. So we'll get x is equal to a e raised to minus omega n zeta plus I omega d plus b e raised to minus omega n zeta minus I omega d. So if there are complex terms in this solution, so we can directly write it in such a manner that taking e raised to minus omega n zeta as common, and a cos omega dt plus b sin omega dt. So this is the solution when there are complex terms. So now let's introduce few constants to solve to modify this equation. So let's say suppose a is equal to n sin beta and b is equal to n cos beta. So what is n and beta? So if I want to find n, so by using the trigonometric identity, that is squaring on both the sides and adding, so I will get that n is equal to under root a square plus b square. Similarly, if I want to find the value of beta, so I will take just ratio, so n will get cancelled, so tan beta is a by b. So beta is tan inverse a by b. So by using these values, I will just put these values here. So to simplify this equation, we have introduced this value. So x is equal to minus omega n zeta. So here n sine beta cos omega dt plus n cos beta sine omega dt. So why we have introduced this values? So as you can see that after introducing these values, so a alpha plus beta formula is getting is coming in this equation. So to get that formula and to modify the constants in the constants which we require, we will introduce this few new constants and variables. So here n will come outside, so minus omega n zeta, and this is sin alpha plus beta plus cos alpha plus beta, cos alpha cos beta, that is formula. So the solution will be sin alpha plus beta. This is alpha and this is beta. So this is our solution. And now we want to find that when is the maximum amplitude can occur. So maximum amplitude can occur when this term is equal to 1. So that is x is equal to, so that is sine omega dt plus beta is equal to 1. Now what is the physical significance of this term n and beta? So this beta and n are just phase difference. So this beta is a phase angle and this n is just a constant. So these are the phase angles. So this was the solution for the first this was the solution for the first case, that is when zeta is less than 1. So we will see few other solutions also in the next lecture. So thank you very much.